problem that we're doing for a device that is 1.8 amps and 110 volts. So for the AP test, you need to make sure that you show this setup right here with this multiplication problem. And you need to make sure that you show either of these two setups or something equivalent to them to show the changing from watts into kilowatts. And then the next thing you'll need to know is how long during the day this thing is used for, right? Let's make up a thing. What is this thing? What? It's a fan. Let's say it's a fan. How many hours a day do we run our fan?
His is 24.
Colin runs his for 24 hours.
Is it okay if we, like, I know from practice before we did kilowatt hours per week?
Uh-huh.
Is that okay?
Yeah.
Okay.
Mm-hmm. Okay. So the per day. So we're figuring out how many kilowatt hours we'll use in a day. 0.198 kilowatts times how many hours in a day do we have this thing running for? Do you see what happens with the unit of measure here? What is that math here? 0.198 times 24. 4.752. That's supposed to be an H right there at the end. My pen ran off the whole of the paper. So the important thing here is that you set this up and show this work right here happening, that multiplication sign with the units of measure. And then a common AP question thing to do might be to then multiply that by some amount of time over the course of a year or a week or a month or whatever, but that would be in the question specifically. So let's say if we wanted to know how much energy is this not Collins fan using in a week, what would we do? Right, because if this is how many kilowatt hours per day, then we just have to multiply it by 7 to get the number per week. Isn't that what you just said?
Yeah.
Okay.
I made it a little more complicated.
Right. Well, and if you do make it more complicated, as long as you arrive at the same answer, AP doesn't matter. Doesn't care. All right. So you can multiply it by 7 days, or you can multiply it by a month. Usually they want you to just use 30 days per month or whatever. Okay. Does that make sense? All right. Let's do one more thing here. What about which one do you want to do? How about there's a TV or there's what is this, a wash machine? Household refrigerator. That's the only one that goes 24 hours a day, though. Let's do one that doesn't do 24 hours a day. Plug in class 2 transformer. Let's not do that one. Let's do the TV. All right, TV. Here we go. So here's the TV. What does it say?
145 watts.
It makes it nice and easy for you. It gives you the watts, so you don't have to calculate. You don't have to do this first part here, right? Because it gives you the watts. So what is it? We're starting out with 145 watts now. How many hours a day do we run our TV for? 1 hour a day? I guess we did kilowatts first, didn't we? Let's do kilowatts first. So 145 watts. I'm just going to set it up a new different way to show you the AP doesn't care how you set it up, okay? Okay, equals 0.14. Oops, that's not how you write 14. 145 kilowatts, okay? And if we run our TV for 1 hour a day, well, we run our TV for 1 hour a day, that's just going to be the answer of kilowatt hours, right?
2.
Should we make it 2? So 0.145 kilowatts times 2 hours per day. What do we get? What is it? I could probably guess it, but since I'm in front of you here, I won't. Yeah, of course. 29. Does that make sense? So what are we thinking about Colin's fan using habits here? Is Colin using a lot of power in his fan? Even though this wasn't actually the data from a fan. Right? So it puts it into perspective. If you're going to run something all day versus run things for a short time, there you go, right? You can actually see the numbers. Now, what about cost? What if we were just throw a level of cost onto this? Do you know how much the electric company charges you to get electricity?
Do they do it like by kilowatt?
They do it by the kilowatt hour. So like this actually would be a really good thing for you to try to do. Ask your mom or dad, whoever runs that at your house, if you can see your electric bill. And you'll find on the electric bill a spot where it will say how many kilowatt hours you guys use in a month. It might be interesting to see. So that's the kilowatt hours in a. You'll find it. The average cost of kilowatt hours in the U.S. is about 11 cents per kilowatt hour. Different regions, of course, are a little bit different. Just like gasoline is different price anywhere, different places in the country. But 11 cents is kind of an average. Maybe 11 cents, 14 cents, somewhere in that range is very normal. Here, I think the last time I looked at my bill, it said 11. We're about average here. So, what if we did have to figure out cost with this? Should we go one more step and figure out cost with this? How much does it cost to run your TV for 2 hours a day? So we have 0.29 kilowatt hours. I think that's supposed to be lowercase, but it's okay. Per day times, if it's 11 cents per kilowatt hour. There you go. Your kilowatt hours cancel out, and you'll be left with. Do you see it here? Anybody do the math already? Oh, what's 11 times? What? 0.0319. Really? I guess that makes sense. Yeah, that makes sense. There you go. So if you're watching your TV, it apparently costs you 3 cents a day to watch your TV for 2 hours.
It's really cheap.
Actually, it's pretty cheap. Sound good? You watch only Jeopardy? That's funny. I wonder how efficient the projectors are in comparison.
Shall we check?
Because that's what we use at our house. We just hook a computer up to the projector and use that. It's probably way less efficient. I actually have no idea. So, all right. Is that helping see it laid out like that? And then the last step maybe here is how do you find the percent column? You add up all the kilowatt hours and divide each one by the total, right? You can do that part, right? Is that pretty straightforward?